All right. Dear all, good afternoon. My name is Luke Rens. I'm Technical Director of EUPAVE, and I have the pleasure to welcome you to the third technical event in 2026 organized by EUPAVE. We already had a webinar on dowels. We had a technical workshop, best practices workshop on surface finishing and decorative concrete. And today, our second webinar, a very special one, on the re-recycling of the motorway, the concrete of the motorway A1 in Austria. It's a very particular project. It is last year, end of 2025, it has won a EUPAVE award. We organized for the first time last year a outstanding innovation award and an outstanding project award. Well, this project has won the outstanding project award. And I read because the jury was impressed by the aspect of recycling a concrete motorway for the second time at such a large scale with high substitution levels, resulting in an EU taxonomy compliant project. That's in one sentence what we will hear now in the nice presentation that will be given by Mr. Stefan Spalt. Mr. Spalt works for Asfinag in Austria. He will present his private-public company and present himself. So, Stefan, the floor is yours. Thank you.
Thank you. Thank you, Luke. Thank you for the friendly introduction. I will start. Okay. You can't see it. I started, you can't see it.
No.
You can't see.
We see your screen, but we see
the
list.
You see my screen. I start the presentation. Yes.
But yes, okay, that's fine.
That's fine. Welcome from Austria to my presentation, the re-recycling of the concrete pavement of a motorway in Austria. First, I'd like to explain Asfinag, that's the company where I work. Asfinag is a state-owned company for operating, building and maintaining all motorways in Austria. I'd like to talk how is the financing of Asfinag. Asfinag, the financing is to 100% by toll, and at 2024, the toll amount were about 2.5 billion euro. You have in Austria, you know, if you cross, you have to pay, all kinds of vehicles have to pay toll. For example, that means in the length of the road network about 1.1 million euro per kilometer network. In Germany, for example, in 2025, it was 1 million euro. What will we do with the money? We have a big construction program. You see, I use the pointer now. You see, the most amount is for the renovation of roads. A little bit smaller are new roads. There is the pointer. Sorry. I'm looking for the pointer. Oh. Doesn't matter. The blue one are the new roads and also new lanes. And the smaller part is investment. That means investments for lorries or for buildings. Now I'd like to give an overview of the concrete roads and the network in Austria. Here you see the construction at the end of 1969. The construction in Austria of motorways started 1955, and all these motorways were made from concrete till 1969, and this part, that's the Brenner Pass, that's a normal asphalt road. 10 years later, we finished the Alp crossing. They are called Tauern Tunnel and Katschberg tunnels. The further expansion you see at the end of at 1989. And now we come to the network status 2024. Here you see that's Austria. And then for me, the interesting things, all roads built in the 50s and 60s, that this part and this part were concrete roads. Now there are also some gray, the gray one is the concrete roads. You see here, these are different tunnels, because in Austria, all tunnels longer than 1 kilometer have to be built in a concrete road. And here, that's a special. We have one PPP project S1, that's also a concrete road. Now we come to the surface age distribution. That's from 2023. The blue one on the left side, you see the total network is 2,280 kilometers. And 1/3 of this concrete roads, 2/3 asphalt. In the middle, you see the asphalt surface, and there is a small part, only 1% is older than 30 years. And on the concrete roads, there are 15% older than 15 years, older than 30 years. And so that's older than 30 years. That means that we have a lot to do to renovate the next years. And these 15% are about 120 kilometers of motorway. And for the renovation, you need about 400,000 cubic meter concrete, or about 150,000 tons of cement. As I told you, in Austria, we have 1/3 concrete roads, 2/3 asphalt roads. For example, in Germany, there are 25% of the total net concrete roads. Now we come to the first renovation circle. First, the first renovation circle started 1990, started in Salzburg. Why did we start in Salzburg? Because the construction 1955 started also in Salzburg, so we had the oldest motorway in Salzburg. And the idea of recycling was in 1990 was an idea by a company, and it was quite successful. And so later this idea became to a standard renovation, that was the standard, it is the standard renovation of motorways. And also in 1990 at the same site, they made the first exposed aggregate concrete, and that's also the standard in Austria since 1990. And here you see the A1 picture from the archive, 290 kilometers, and the concrete volume about 700,000 cubic meters. So what was the motivation in the 90s for recycling? First one was to conserve of natural resources, limited landfill space, with use of transport or transport distances. And that is possible, you need the presence of a homogeneous starting materials with properties grown over many years. Yeah, we know our concrete roads and we have the experience. But now I come to the most important thing, the economical, because in the 90s you could save about 10% of the money. Here we see a recycling area at the left. The recycling, the pictures from 1996. You see the two parts for the concrete production, one part for the top layer, one part for the recycling layer. And here on the right, there is the crushing plant. And yeah, and you see this area is directly at the site, at the construction site. So you have short transportation, and short transportation is important because for a good project, for a good concrete roads, you have to bring the concrete just in time. And if in the morning the machine is starting, the machine should only stop once a day in the evening. Yeah, for the on this picture you see the how it was possible to recycle. The 100% of recycling. That's the old road. Actually, in the last years, they put a thin asphalt layer on top. Then this part, all concrete parts, came 70% from material 4 to 32, was the recycling layer, used in the recycling layer. And and 30% materials 0.4 for the cement stabilization. Now we come to the second renovation circle. What do you need for the second renovation circle? Yeah, the most important thing is you need a recycled roadway, of course. Without recycled roadway, you can't re-recycle. And then you have to check the materials. And one important thing, or the important thing, is the preliminary investigation of RSR. That's the alkali silitic acid reaction. We checked in advance and it was okay. And then in advance, we hired the land directly on the construction site, and we gave it to the company, to the construction company, and in this time we also checked in advance the official approval procedure. And in our case, we didn't say you have to recycle, but it was possible to recycle because we hired in advance this area. And the company who won, he said he'd like to recycle. And so, yeah, we started the recycle process, and they checked the recipe, and then we were working together. And I didn't hear before about the EU taxonomy. And then together with the company, we said, oh, let's try. Maybe it's possible to make the construction including the regulation of EU taxonomy. And on this picture, I'd like to explain. Here you see the different materials. That's the material 32 millimeters to 16 millimeters. That's 16 to 4. That's new materials, and this materials is 0-4 recycling materials. And the company, you have to design the recipe. The recipe must be designed so that the material of any group is used at the end. So that's the reason why all recipes are different on each side. So now let's see the EU taxonomy regulation. There are 5 points, and we check together, is it possible or is it not possible to reach these 5 points? The first point, you have to recycle all materials unless it's not contaminated. That was very easy because that's daily business. Nobody would waste good materials. That's daily business. The second point, not so easy. You have to at least 50% of the new structural road elements must be consist of reused or recycled materials or non-dangerous industrial byproducts. That means a part of the cement is a non-dangerous industrial project. I explain later how we reached this by the recipe. Then there is a limit of transport distance. That was no problem for us because the recycling area was directly at the site you saw. The new lifespan of the binder layer should be over 20 years for concrete roads. It's no problem because in Austria, concrete roads are designed at least for 30 years. And number 5, that was very interesting for me, the resistance system. For example, the steel, it's only allowed to use 30% of primary raw materials. And these steel retaining systems, actually in Austria, they have about only 70% raw materials. So we changed the system and reused the retain systems. And if you reuse, you have a recycling of 100%. And at the end, we could reach about a recycling of 80%. Now we come to the recipe. The recycling is this part, is the yellow part. And you see on the left, there's the average of all recyclings on the A1 Westautobahn between 1991 and 2010. There we had a recycling rate about 60%. In the first recycling at Monse Talga, we had a rate of 55%. And then for design the recipe and say we'd like to reach the EU taxonomy, we know we need at least 70%. And now you say, oh, 70%, that's much more than 50%. Yes, but 50% means the top layer and the bottom layer, and you can only recycle the bottom layer. So the top layer is always a new material. And what did we change? We changed that you see the material 04. There is only a part of the material 04 is only is for recycling. It's possible in Austria to recycle this material also. We asked the company, you can do it, you can manage, because it's very hard to get a smart mixture of concrete if you use these materials. And the company who mixed the concrete has experienced more than 30 years for recycling concrete, and said, yes, we do it. We can manage. On this picture, you see now from the recycling to the re-recycling. 70% we recycled 70% in the bottom layer. From now, first it was 432, now it's 032. And the last 30% we used for the cement stabilization. Now, the conclusions. We are really proud for the first time of successful recycling. And I think now that should be a footprint for further renewals of concrete motorways in Austria, because now we have renovated 7.5 kilometers, but 280 kilometers still missing. We showed that it is possible building motorway according to the EU taxonomy. And I think the most important thing is number 3. There are the costs. We could save again about 10% of money for the concrete. And for the future, I think recycling should be possible. Yeah, that should be possible. Yeah. So, first of all, thank you for attention. At the end, we can enjoy a movie. And here you see the construction site. That at the end, that is Lake Monse, and maybe on this area here is the village Monse. There is a famous church, and there they made the movie Sound of Music. And if you know it, I invite you to visit me in Austria. I can show you this wonderful project. Yeah, and also we can see where they made in the world famous movie Sound of Music. So up to now, thank you. And now I start the movie. The movie takes about 5 minutes. So I can't stop the presentation.
The presentation is stopped.
Yeah, thank you. No, I have to just a moment to share again. And I start the movie. Here you see 1990, they made also a movie for the first recycling. Here we see the recycling area and the crushing plant. Here the cement stabilization. And in Austria, we built on the bottom layer 5 centimeter of asphalt before we make the concrete roads with the slip pave former with lower layer and top layer. The lower layer is the recycling layer. Now we come to the re-recycling. We just did the same. First, you have to destroy the concrete. Then to remove the seal, because we don't like the seal in the bottom layer. And yeah, you bring the material to the recycling area. Here we see the recycling area and the crushing plant. And here we produce 3 materials. Here we see the material, the most important, 16 to 32 millimeter. Then 0 to 4. That's this material. And 416. That's the material 04 for the concrete stabilization. Here you see the machine in action for the concrete stabilization. Then the bottom layer of asphalt, 5 centimeter asphalt. And here is the production of the concrete. We also have 2 productions. One production from the recycling layer and one production from the top layer. Here we see the top layer. The top layer, always you have to use a new material because it's important for the grip and yeah, for the grip because we used exposed concrete. That's the bottom layer, the recycled concrete. And then they bring the concrete directly to the slip home paver. That's the recycling concrete. The end you see the drain system. In Austria, we use a drain system. Yeah, that's the top layer on the recycling layer. Yeah, we use towels. Each 25 centimeters means 4 towels per meter, and tie bars, 3 tie bars each. Yeah. And at the end, we see the texture curing machine, and we made exposed concrete of all lines and grinding on the 2 lines where there is traffic. And the grinding was only for evenness. And we could reach a wonderful evenness after the grinding. So thank you. Now I'm at the end of my presentation. I hope you could enjoy, and maybe we see us in Austria or in Malaga. Thank you.
Thank you so much, Stefan, for sharing with us this wonderful experience and really amazing work site. Can you give some figures? What was the length of the work site? Do you have volumes of recycled aggregates?
Thank you. Yeah, of course. The length was about 2.5 kilometers, also each side 7.5 kilometer, and the costs were about 80 million euro in 2.5 years.
Yeah, I made some calculation. I think it was about something like 500,000 tons of recycled aggregates that were used.
So yeah, actually, I didn't calculate.
I have a question from Zolt Boros. He says, what was in fact the reason for the rehabilitation of the recycled concrete roads? Was there already serious deterioration? Were there a lot of distresses? Or was it based on a pavement management system before the road failed?
For the recycling, or why we did?
Yeah. Yes. Why did you need to do the renovation of the motorway?
The motorway was old 35 years, and after 35 years, even a concrete road can die. It's okay if they died. So that was the motivation. And I have to explain that was the first recycling in Austria. And so I'm sure the renovation afterward, they can live longer than 35 years. This was the first renovation, and for a pioneer project, 35 years, I think that's okay.
Yeah. I'm not doubting about that. But I also checked the material 04 that you used, so the sand fraction.
Yeah.
There you used about 72% of new materials, but 28% of recycled, which is quite high for the 04 fraction. And were there no problems during construction, or did everything go fine, or did you maybe adjust sometimes?
Yeah, of course there were problems. The boss of the concrete, he is producing recycling concrete since 30 years. And of course, during the process, he can change the recipe a little bit. Add 2 liter water here, add some more, less 04, more. And so he did it all the time. And this guy went to the driver from the slip from paver, and they just look each other. And if the driver of the slip from paver is happy, it's okay. And he see what's the problem. And even the slip from paver driver is calling. They know each other and said, 1 liter water more, 2 liter water more. So
So
it's very, very sensitive, and
yeah,
you
so
need
it was
a lot
based on
of experience to do it. And also, we were lucky with the weather. We did it not in summer. We started at the end of August, so it wasn't so hot. And I think the most thing is the experience, because I know other project, the man who is making the concrete said, oh, my concrete is perfect. I am in the tolerance of the recipe, but at the end you can't work with these materials. So it's better you are at the end of the recipe and he can work on the side. But
so I
the most thing
understand
is the experience.
Yeah, experience and also based on a continuous monitoring and communication system.
Yeah.
That's great. Are there maybe any other questions from the audience? You can write them either in the Q&A chat.
If there are no questions, I have no problem.
I have one more.
I hope we can see us in Malaga.
Yeah.
You will find me in Malaga with my traditional Austrian trousers. So I think I'm the only guy with such a trousers there.
Yeah. I have one more question, Stefan.
Yes.
Do you see potential to increase use share of the recycled 04? What was the limitation there? Yeah, I think. Maybe I already answered, because the 28% is already high for the 04. It's
in the first recycling circle in the 90s, they tried to use all 04. And they said sometimes it was possible, but sometimes not. But they didn't know, does it work? Does it not work? Maybe no, I think it's not possible more.
No, it's very challenging.
Yes.
It's also a risk analysis, but I think it's really worth saying that those 28% are really a good share of recycling. And then the question is also, what type of crusher was used for recycling? A jaw crusher or a HSI?
A normal, I don't know how it's a Backenbrecher. I don't know the name. It's like this. It's not a mill. It's doing only like, I don't know in English.
The jaw crusher, I guess. Yeah. Zolt Boris also thanks you for this excellent report. It seems very easy to say, but I can imagine it's a lot of work behind. What do you think? Why do the other countries do not recycling like in Austria? Yeah, that's a good question.
That's a good question. Yeah. Yeah, for recycling, you need a perfect concrete. And we are very happy with the raw materials we find in Austria. And we have no problem with the acid, no, the silicium reaction. So
ASR.
ASR, thank you. But also, I think in Austria, we tried. I think in the 90s, we just try to recycle by doing it, just doing it, and it works. And also sometimes Germany, they ask me, what are the rules for recycling in Austria and what are the difference? And I said, yeah, there is no difference. you need homogeneous materials for recycling, and then we just check the result. We check we don't. For us, it doesn't matter if it's a recycled sand or corn, or it's a new corn, because at the end we need concrete, and the concrete have to reach the festigkeit,
the strength. Yes,
that's the
I have
strengthness.
also a question. So what you mean is that it's basically performance based, and so I also have a question. Two questions: what was the strength of the concrete, and were there other tests done for the design of the concrete recipe other than compressive strength? Or
No, yeah, the normal we use evenness, but the same we use for new materials. Yeah. It's the same. It's just the same process.
Yeah, probably also flexural
for
strength.
The resistance of frost. It's called frost.
Yeah, freeze-stone resistance. Yeah.
We don't check it. We don't check it because we have to know that the starting material, the starting concrete, is frost resistant. And if that is frost resistant, because this material in recycling, the tests from recycling materials, they are not so easy. So we just checked for frost if the starting concrete is resistant. And we do it.
What was the design strength of the bottom layer of the recycle?
Designs the thickness, or
no, the strength, compressive strength.
Oh, I don't know. That was that actually no, I don't know. Maybe
no problem. Then there's also a question about the density of the 70% recycling. It was 2,208 kilograms per cubic meter, which is rather low. What about the porosity?
Yeah, we were in the range. In the range, we have I think up to 8%. Luftporn,
so air entrained.
Yeah.
So okay, then I think it's a reasonable thing. I think in that case the combination of the lighter weight of the recycled aggregates and also the entrained air, then is 2,208 indeed possible. So let me check. So there was other two questions about on the same. Were there special measures to manage the water content of the mix? Because you have more old mortar around the aggregates, which make the recycling more difficult. And a second question, similar, how was the increased water absorption and permeability of concrete managed with use of high percentage of recycled aggregates? So basically
that's very special because I didn't produce the the concrete. Actually, it was a normal standard mobile concrete. Mobile concrete. How is it called?
A mobile plant.
Mobile plant. Yeah. And for this question,
I
please,
think maybe you gave the answer already in the previous question when you told about the small adjustments that are being made during construction.
Yeah, of course.
The experience of the slip-form paver operator together with the man on the work site, and as you said, that for each batch there are small adjustments, a little bit more, a little bit less water.
Yeah, of course, yeah. And
Because
also there
indeed,
are
because when
difference
I checked
between morning and evening. If the temperature are higher, they adjust.
Because the concrete mixes
they
that you
adjust
showed.
not automatically.
No.
That's all manual. Oh, that's.
So
Okay.
I think that the yeah, let's say the success is lying basically in the quality control on the work site and the continuous monitoring. You cannot think I have one good mix, so it will be good for the
Of
work
course,
site.
yeah. Luc, the presentation will be shared at the end. There is my contacts. Please feel free and
Yes. So
write my
Elise will make
questions.
the presentation available in PDF on our website, and will inform all participants of this. So I thank you all for attending this webinar. Thank you, Stefan, for sharing this really amazing project. It's
Thank you.
I'm still very happy with the outstanding project award that you won for this. It's on such a large scale with those substitution rates. It's really exceptional. So it's really, I guess, a worldwide example. It is the example for me of circular construction. So thank you so much.
Thank you.
Thank you all. Hope to see many of you in Malaga for the 15th International Symposium on Concrete Roads from 3 to 6 November. Stefan will also be there giving this presentation again. So thanks again. Follow us on our website, register for our newsletter, and we'll see you back. Bye-bye.